Emma, and I like ham radio. Today we're going to learn about voltage!
So maybe you've seen signs that say, warning, high voltage. Have you ever wondered what that means? What is voltage?
Is it how much energy is in a wire?
That's really close. Voltage is a force that makes electrons want to move. It's a bit similar to pressure. See this pop can? If I crack open the top, what will happen?
It'll go pshh.
Okay, so what happens if I do this?
It would spray all over.
I won't. If I opened it, not just gas would come out, right? But the pressure would force the liquid to spray out too. In the electrical world, this is kind of like a battery. A battery stores energy that's sort of under pressure. When you connect the ends with a wire, you give the electricity somewhere to go, and the electricity, it starts flowing.
Yeah, but it's a lot less messy.
I'm going to tell you another scientific name for voltage, and we can pull the words apart and see how it makes sense. It is electromotive force.
That's a mouthful.
Yeah, but let's look at it closer. Electro refers, of course, to electrons. Motive, if we turn that into a verb, it's motivate, which means to get someone or something to do something.
Like if you motivate a runner, come on, you can do it, let's go!
Exactly. And then the last part is force, which is something that can cause something else to happen. So when we put it all together, electromotive force is a force that can motivate electrons.
Ah, I get it.
In science, we can measure forces, and voltage is no different. We need a unit of measure when we're measuring something, right? Otherwise, the numbers don't mean anything. If I told you that I was 72 tall, would that make sense to you?
Huh?
What if I said 72 inches tall?
Ah, right.
See, when we're measuring height, we can use inches or feet or meters. The thing that we're measuring is height. The units are inches, feet, or meters. In the case of voltage, the thing we're measuring is the force, and we use a unit called the volt. Okay, so if we were to use a ruler or tape measure to measure height, what would we use to measure volts?
A multimeter?
Yeah, that's what it's usually called. Technically, we use a voltmeter to measure volts, but the meter we normally use can do more than just measure volts. So we call it a multimeter because it has multiple functions. Okay, so now that we have a way to measure voltage, where might we find voltage to measure it?
Batteries!
Yep, if you're a kid, that's the safest way to measure voltage. Things like electrical outlets on the wall, they also have voltage. Those are way too dangerous, even for adults.
Even for adults?
Yeah. So let's talk about why for a moment. Emma, do you know what voltage a AA battery is?
I think it's 1.5 volts. I put two together one time to light up an LED.
Yeah, that's right. A AA battery has 1.5 volts. If you touch both ends of a AA battery, what happens?
Nothing really.
Yep. 1.5 volts really isn't enough to push electricity through your skin and through your body. What about a 9-volt battery?
I've touched those before and I didn't get a shock.
Yeah, I mean, if your hands are dry, nothing will happen. If you touch the 9-volt battery to your tongue, though, you will get a little shock.
Really? Does it hurt?
I wouldn't say it's a pleasant feeling, but it's not really painful. The thing is, technically, it could kill you.
Whoa, really?
Yeah. If the same amount of electricity flowing through your tongue was flowing through your heart, it could disrupt the electrical signals your brain is sending to your heart and make it stop. But because it's only flowing through your tongue, it's not dangerous. 9 volts isn't enough to send electricity through your body to your heart. That's why it's okay to have batteries in kids' toys. If they fall out, they won't hurt kids. And we can do some experimenting with them.
Okay. Phew!
Okay, but what voltage is an electrical outlet?
More than that, probably.
Yeah, see, in the United States, where we live, an outlet is between 110 and 120 volts. That's a lot more than 9 volts, and it can send electricity through your heart. That's why we will not be doing any experiments directly with electrical outlets in any of our videos. We might be using a plug-in adapter sometimes though, but those are devices made by a company that knows how to safely handle electricity. Do you know why we use power adapters?
To change the voltage?
Exactly. Many times the devices that we use need a lower voltage than 110 volts. For example, most radios that sit on a desk take the same voltage, but it's not 110 volts. Do you know what it is?
I don't remember.
I'll give you a hint. It's the same voltage as a car battery.
12 volts?
You got it. Most ham radios use 12 volts, and they need a power supply that plugs into the wall and changes the 110 volts down to 12 volts. But if you install the radio in a car, you don't need the power supply because the car is already supplying 12 volts. Okay, now that we've learned a bunch about voltage, what's next?
Let's get hands-on!
Okay, ready? We are here and ready to do some hands-on electronic stuff. So what we've got is we've got a multimeter. Yep, and this multimeter was pretty cheap. It came from Harbor Freight for like, I don't know, I think it was like $5. So I want to point that out because just so that kids know that you don't have to spend a whole lot of money to do electronic works.
No, you don't.
So what we're going to do is we're going to measure some voltages. Okay?
So here are the leads.
Yep.
This is what you use to measure them. The red goes on the positive side of what we're measuring, and the black goes on the negative side, so that's important to keep in mind.
Yep. First thing we got to do here, though, is got to get our multimeter. It's got the big dial, and it's got a whole bunch of different features that you can turn on, right?
So first we have to turn it on. Like,
yep.
You can't do anything with an off multimeter.
Yep. And so there's each, if you notice, there's different sections here, and they're labeled. Oops, I'll get my hand out of the way. So this section up here is labeled DCV. What does that stand for?
DCV stands for direct current volts.
Right. And there's also an ACV section, but we're going to leave that one alone because that's for measuring what?
Alternating current.
Yeah.
You'll learn about that in the next video.
Yep. But that's too high for us to measure. The voltage is too high, right? So we're going to leave that one alone. It's even got a nice little red outline around it. So, but we can measure some batteries. We got a selection of batteries that we're gonna measure, and so we got to figure out though, make sure it's on the right setting. So, do you know what the M stands for?
The M stands for.
It's okay if you don't know. That's right. We didn't really talk about it in the video.
Yeah.
So what that stands for is millivolts. So it's a tiny volt, right?
Okay.
It's small.
So that's why we have 2,000 and 200 instead of just having 20.
So this is 200 millivolts. This is 2,000 millivolts. This is 20 volts, 200 volts, and 250 volts.
Yep.
Now, hopefully, we're not going to be measuring anything that's 200 volts.
Nope.
And nothing that's 250 volts. But do you remember what voltage we're going to be measuring? We should be expecting?
Well, we should be expecting 1.5 volts. So what should we use for that?
Let's do 20, because that goes from 0 to 20.
Okay. So we'll do 20.
All right. So let's grab our first battery. Let's do just a regular old AA. Yep.
A non-rechargeable AA.
Yep.
So now we take our leads. We gotta make sure which side is the positive and the negative. So
right. Here, I'll hold it.
Usually the batteries are marked positive or negative is positive. And then so we put the black lead on the negative, and then the red lead on the positive.
Here, let's do this. Let's move this over here so that we can see on screen. So what are we getting here?
So we're getting
Gotta
about...
hold it on there tight. Sometimes it's a little hard to get it on there. This battery seems to be reading. This one might be dead.
Ugh.
Let's try a different one.
That one wouldn't work in any toy or anything because...
Let's try the other one that's like this.
Okay.
Okay. We'll set this one aside.
So that one doesn't work.
Okay.
So let's
try
test this one.
Here, let me turn it around.
Okay. So let me look at that one. Doesn't look like... It looks like this one's dead too. So
That's weird. Let me just check it here a minute.
we have one more battery that we can
Let me
use.
hold it to here tight and tight. Yeah, that's not registering at all. What's going on with that? Okay.
So we have another dead AA battery. So we'll use probably
Here, you do it.
we'll check this other battery. It's a different kind of battery. So we hold it on there tight.
Oh, look at that.
That's our reading.
Okay.
There we go.
That's 1.3, right?
Yep.
So basically, what we're looking for is 1.35. Anything that or over is a good battery.
So this one would be okay to use for lighting LEDs or doing anything else that you need just a little bit of voltage for. So
now,
you
if
could
it
put this one in a little toy.
So if it was 1.2 to 1.3, that would be okay, but it's almost dead. And then anything below 1.2, just you need to get rid of it, discard it.
Yeah, it won't
Recycle
work
it.
anymore.
Yep.
Okay, so we're gonna try a different one.
Yeah, let's try the AAA a minute.
Okay, so we're gonna test this little AAA.
Okay.
It's much smaller than the other
We're
one.
gonna get on this one here.
And so we're getting
1.3. That seems like
so
it's
we've
good.
got 1.37. So as Daddy said, 1.35 is the best. And here's a comparison of size.
Well, okay, so I have a question for you. And maybe you know this answer and maybe you don't.
Okay.
These batteries are two different sizes, right? But they both have the same voltage. Why?
I don't know.
As it turns out, a AA and a AAA have the same voltage. They just store more energy.
Oh, so that makes sense why the AA is bigger than the little AAA. Because it stores more.
Yeah, so it would last longer. So if you had just the AAA, maybe you'd get a couple weeks out of it. If you had like it depends on how much you're using.
Yeah.
But if you stuck this one in the flashlight and you stuck that one in the flashlight, the smaller one would last longer. Would last shorter time.
Yeah.
Right. If you were to measure a C battery or a D battery, they're also 1.5 volts.
Which we have a...
That's not a D, actually. We'll show that one next. This one is... What does it say on there?
It's a 9-volt battery. So remember how we talked about the 9-volt on your tongue? That's the 9-volt that we used.
But let's not stick it on our tongue. Let's just
measure it. That's a good idea.
So remember, there's a positive.
So you should see the positive.
And there's a negative. So let's do it that way. So go ahead. And look at that. More than 9 volts. That's good. See, some of these batteries don't have exactly the voltage that's on there.
Yeah, they have a little bit of wiggle room.
Yep.
So
that's great.
Either up or down, it doesn't really matter.
So that's a 9-volt battery, right? Okay, well, we did some batteries, and we tested the voltage of some batteries. Now we're going to test the voltage on a circuit. And to do that, we are using snap circuits. And Emma created this little circuit and snap circuits, and so she can explain what she did.
So this is the battery. That's where it gets the power from, because you don't have a circuit without batteries. And then it goes through the switch when the switch is on. If it's not on, then the current doesn't flow, and there's no current going through. So it goes through here into the resistor, which is like the turnstile in the Electric Rock concert. And then it goes through what is called an LED. It stands for a light emitting diode.
Good job.
So then it comes through. Well, we'll explain all about these components later in later videos, but for now, simple explanation for now. And then it goes back to the battery and repeat.
So we've got two batteries here, I notice. What should be the voltage then for this little circuit?
Well, both of these are 1.5 volts batteries. So that would mean if you added the voltage together, it would be 3 volts.
All right, should we check it?
Yes. So I have my leads, and there's the positive sign and the negative sign.
Okay.
And so I have my positive and negative leads, and we touch it to here. Look at that.
2.58-ish. I'm guessing that the batteries are a little bit dead. So they're not quite 3, but pretty close.
Yeah, but pretty close.
But enough to light the LED. You want to turn it on?
So now we're closing the circuit.
Yep.
And the LED lights up.
There you go.
Turn it off. No LED.
Now, one of the things we should talk about too is that, remember we talked about voltage is you can measure voltage even if it's not flowing. Remember the electrons, they want to go somewhere, but doesn't necessarily mean they are.
Yeah.
So that means we can still measure voltage even if the switch is off, right?
So the switch is off right now, but look.
Now there's going to be some places that we can't measure. So
like watch.
Yep. There's a little bit there because we're still, what's happening is we're measuring it through here, and then it's going through here and getting to here. So those will work. But what about here and here? 0.
Nope, because it's on the other side of the switch.
Right, and there's these are not really connected right now. Now if you were to turn
But if I did this.
Yep, you'll get a little bit. And the reason is, now this is something we haven't really talked about yet, but when the voltage goes through things like the LED and the resistor, the voltage changes. So you're going to get different results depending on what you're recording through, like what you're measuring through. So that's okay. So it's not going to be 3, but it isn't 0, right?
Yeah.
Okay. So
do you want me to turn it on?
Sure.
Okay. So we'll turn on the circuit. So LED is lit. That it's just our indicator to show.
Yep, circuit's on. That's 2.5. Now what about over here? Not 2.5, right?
No, it's not.
And like I said, we'll get into but it's because of this little resistor here.
Yeah.
And it changes the voltage, but it's not 0 either.
Nope.
Now what happens if you go here and here? 2.5.
What?
Because you're measuring from this side of the battery and then this side of the battery. You're measuring at these 2 points. It's not going through the resistor.
Yeah.
So that's why.
So we'll turn the circuit back off to save power.
Okay.
Because we don't want to drain our battery.
And that's how to measure voltage in the circuit. What is the electrical term for the electromotive force, or EMF, that causes electron flow? A, voltage. B, ampere hours. C, capacitance. Or D, inductance.
Is it A for voltage?
Correct. Yep, it's voltage. That's the other name for electromotive force. What is the unit of electromotive force? Is it A, the volt, B, the watt, C, the ampere, or D, the ohm?
Is it A, the volt?
Got it. Good job. How much voltage does a mobile transceiver typically require? A, about 12 volts, B, about 30 volts, C, about 120 volts, and D, about 240 volts. So in this case, when they say mobile transceiver, you know what that means? Okay, mobile transceiver is another way of saying radio.
Okay.
So a transceiver is both a receiver and a transmitter.
Oh,
So they call it a
sense.
transceiver, right?
Yeah.
So this would be like a radio that we mount in a car. Okay? So you remember we talked about the voltage that we would use in a car.
Is it A, about 12 volts?
Got it. Yep. 12 volts. That's how much a car runs on. And it's also, if you have a mobile transceiver, you can mount it in the car. And you don't need a power adapter or anything like that. Which instrument would you use to measure electrical potential or electromotive force? A, an ammeter. B, a voltmeter. C, a wave meter. Or D, an ohm meter. So a couple of those are different functions of a multimeter, right?
Mm-hmm.
So
Let's see. Would it be maybe B, a voltmeter?
you got it. It's a voltmeter because we're talking about voltage, right?
Yeah.
What is the correct way to connect a voltmeter to a circuit? A, in series with the circuit. B, in parallel with the circuit. C, in quadrature with the circuit. And D, in phase with the circuit.
So could you explain some of those answers
Sure.
for us?
In series means that the electricity would flow through the voltmeter. So it would go in parallel means that the electricity would be flowing by and we're measuring the voltage at two different points. In quadrature, I can't explain that one because it's not really a thing. So in this case, we really can eliminate that one.
Yeah.
In phase is also not quite right. So I'm kind of giving you a narrowing it down a little bit. But that's okay. If you were to run across this one on the test, you would know that quadrature and in phase, those aren't really ways to hook up a voltmeter. So really it comes down to, do we put it in series or do we put it in parallel?
Well, I think we put it in parallel, so it would be the answer B.
You are correct, in parallel. So basically we don't need because voltage isn't flowing, we don't need it to go through the meter.
Right, because it only wants to flow.
Right.
It doesn't flow. Though.
That's it.
Yep, we did it.